Now we're on to discussing absolute value equations and inequalities. One of the key things we need to remember here with absolute value equations and inequalities is that you must isolate the absolute value first. That's priority number one. So number one, this absolute value is already by itself. And then what we saw with absolute values is that the absolute value of a variable expression equal to a number means that the inside has to be exactly that number, or the inside has to be the opposite of that number. And of course, we do want to remember that this guy, A, has to be positive. I mean, it could be equal to 0, but that doesn't really help us out much. So that means according to this guy, the absolute value of x plus 2 equals 13 means that the inside, the x plus 2, must equal 13, or the inside stuff has to equal the opposite of that, negative 13. And you know that's true. If I were to have a negative 13 here, the absolute value of a negative 13 is positive 13. Okay? So when I solve this, I get x is equal to 11, or x is equal to, subtract the 2, negative 15. So we can very quickly get our two solutions here. Now look at number 2. I said you need to get the absolute value by itself first, so if we divide both sides by 2, we have the absolute value of x minus 7 is equal to 4. So that means that either x minus 7 is equal to 4, or the inside stuff, x minus 7, must equal the opposite, which is negative 4. These are two small linear equations to solve. Move the 7 over and you get 11. Move the 7 over here and you would get a positive 3. And these guys are fairly simple to check against the original. If I were to plug in 3, 3 minus 7 is negative 4, but the absolute value of that is positive 4, times 2 is 8. And you can easily check 11 as well. Let's look at number 3. In number 3, we need to get the absolute value by itself, so move the 8 over. So the absolute value of 9 plus x is equal to 3. And what we've already seen, that means that the inside stuff, 9 plus x, has to equal 3, or the stuff inside the absolute value has to equal the opposite of that, which is negative 3. So solving for x, you get negative 6, or x is equal to negative 12. Same thing here in number 4. This absolute value is already by itself, so that means that 3x minus 17 equals 13, or it equals the opposite of that, negative 13. So you have two equations that you need to solve. In this first one, add the 17 to the other side, and that gives you 30, which means that x is equal to 10. Over here, when you add the 17 to the other side, you end up with 4, and then x is equal to 4/3. Again, you can check this stuff with your graphing calculator. So to do the absolute value of 3x minus 17, you press math, press to the right, and there's the absolute value. So when you hit enter, it brings it up on the screen where you just were. So the absolute value of 3x minus 17. And on the other equation, I want to graph 13. I want to see where these guys intersect. I'm going to go ahead and change the window here because I know it's not going to work out very nicely for me just yet. So make your x-min from 0, x-max to 20, and your y-min from And we should be able to go from 0 to 20 here as well. So this here is the absolute value equation. It's a V-shape. We've seen that before. And then there is y equals 13. So you see there are two intersection points. Here, when x is 4/3, and here when x is, what do we say that was? 10. Yeah. So it all checks out. Now let's look at absolute value inequalities. When you have the absolute value of x being less than a number, then it becomes this. X is less than that number, but also greater than the opposite of that number. So you create a three-part inequality here. This is what we call, at least what I call mother hen. You want your distance to be less than 5, so stay within 5 units on the other side of that. So this guy gets rewritten to be x is less than 5 and also greater than -5. Well, you already have x by itself, so this is fairly easy. When you graph this, here's -5 and here's +5. We are saying that our solutions have to be within this area. You want your distance to be less than, so you're restricting the distance. And then from here to interval notation is just from -5 to 5. Now, it's this next guy that a lot of times we have issues with. When you have the absolute value being greater than, that means that the stuff inside has to be greater than that number, or, this goes back to those compound inequalities from the other day, or x is less than the opposite of that number. You may not do this. You do this and you're going to be wrong. So that means that the stuff inside the absolute value has to be greater than or equal to 4, or the stuff inside the absolute value has to be less than or equal to -4. Notice that these have opposite directions. The first guy is just the original. You flip this and you change the sign. So here, when you solve this, you get x is greater than or equal to 2, or x is less than or equal to -6. Remember, the word or corresponds to union. Because, see, I want your distance. I want the distance to be more than 4 units on either side. That means I want to separate, I want to spread out. You have to stay away from me by 4 units or more. So, in this case, it's accomplished by being at 2 and greater, or equal to, being at -6 and going out to the left. So you basically have this saying, stay away from me. I need you to stay over here and stay over here. This is the opposite of mother hen. This is the angry mama. So stay away. You have 2 sections where you can be. So in interval notation, that's from -infinity to -6 with a bracket. Union from 2 to infinity. If you try to make it one string of inequalities, you'll see that you end up with a contradiction. That's why you have to separate here. In number 7, just like I told you before, you always want to make sure you get the absolute value by itself. So add the 7. So the absolute value of x minus 5 is less than or equal to 10. Notice this is less than or equal to. I want the distance to be less than. That means don't go away from me. Stay close by. So I can make a string of inequalities being less than or equal to 10. And on the back side here, greater than or equal to -10. As you read from left to right, you see that the order does make sense. -10 is less than +10. So to solve this, we just add 5 to all 3 pieces. We have -5 is less than or equal to x, which is less than or equal to 15. So the interval notation, you see that x is in between both of these, including both, so it's from -5 with bracket to 15, close bracket. Well, let's look at number 8. See, now this one has the distance or the absolute value being greater than 17. That means I need you to stay away. So this guy wants your distance to be greater than 17, or, so this is where the union comes in, it wants your distance to be on the other side, so less than negative 17. So on the other side of the number line, on the left side of negative 17, positive side of 17 here. Solve each of these. So negative 2x is greater than 8. Here, I divide by negative 2, so we have to pay attention. X is now less than negative 4. Over here, so I get negative 2x, subtract the 9, so that's less than negative 26. Divide both sides by negative 2. X is now greater than positive 13. So if you were to put this on a number line, here's negative 4 and 13. Less than negative 4 is going out to the left. Greater than 13 is going out to the right. So you see, we're kind of trying to separate. Stay away. And the interval notation goes from negative infinity to negative 4, union, parentheses, and that's 13 to infinity.